Welcome to our first live stream, Future Food System live stream. I'm really excited to have Jeremy here, who's a real architect, unlike me. And yeah, want to acknowledge the traditional owners of this land for letting us build this house on their sacred land. And here we are, it's the greenhouse Mark V, and we're going to take you through all the different elements that have made this building what it is today. We're going to actually start with the water container. And this idea came about when the bushfires went through in 2009, and quite a few people actually passed away because they thought they were safe, they thought they had pumps, they thought they had plenty of water. And because of the ambient heat that came before the fire, a lot of pumps exploded, and that's when I thought, why don't we turn old grain containers into places that can actually protect. So this has got a seat in it, and it's got a waterproof membrane inside it. And this idea will be completely open source. So Tim Gibney and Associates have engineered this building, this structure, and it allows you to basically have 30,000 litres of water in case of a bushfire. And it's protected by water and by the container itself. So this will have a pump, and the pump can be changed over so you can actually use it for firefighting.
So you can use it as a pool and as
you
a
can
water
use it as a
tank
pool.
and it's for firefighting. So it's not just 30,000 litres of water sitting there not doing anything.
Well, the hope is that you never actually have to use it for that reason, but you get to use it every day as a swimming pool.
Yeah.
And what's so great about this is EnviroSwim, which is an Australian company that makes these completely natural pool systems that use copper to filter the water and an electric current. No chemicals, completely
no chlorine?
chemical, no chlorine, no salt, no nothing. So I can't wait to do a bomb into this baby. And then you can see here.
So everyone will be able to see you from Fed Square doing a bomb into
it is a
Matt
little bit
and
hard,
Joe's
so you
pool.
might not know that anyone's in there.
Yeah.
But there's a seat up here. And then we've got a tiny little roof up the top, which is, I've calculated, is enough for drinking water for a year. And we've got a stainless steel tank. So all the water off the solar panels of the roof will be used for drinking and cooking and that sort of thing. And that's what this stainless steel tank is for.
So how big's the whole house? Or how big's the...
87 square metres is the footprint.
Okay.
But with the pool, it's 100 square metres.
Okay, and the average size of the Australian house now is 250 square metres. So you're like
Wow.
1/4 of the size of that.
Yeah.
And you're going to catch enough water for Matt and Joe to be able to drink?
Well, I mean, we've only got, 2/3 of the site is actually getting used for food production.
Yeah.
So that water's being separated. So it's only really 1/3 of the site that we're using for drinking water.
Okay.
Yeah.
I've got to see how the toilet works in here.
Well, yeah. Come through. So you can see here as well, this is a really incredible design. A couple of guys that I don't know what they were drinking or smoking when they came up with this, but they somehow managed to bend corrugated iron. So anyone that's worked with corrugated iron knows that it cracks and it's impossible to bend. But this is a really radical change because from a bushfire point of view, it means that you can't have embers entering on the corners. And yeah, it's a really, really incredible, simple, and I think it's actually very Australian design. You can't imagine it.
So you're talking about how the corrugated iron comes along one wall and then they just fold it around the other wall rather than two pieces finishing and then having a daggy flashing in between it.
Yeah.
It's actually, from an architect's point of view, it's actually really beautiful.
Well, it's like, what a great way to finish it, and vermin proof as well.
Yeah, and super efficient.
Yeah.
Yeah, okay.
And completely recyclable at the end of the building's life. You can see here as well, this is the first building that I've done, the second actually. I did the Lexus Pavilion the same way, where I haven't used light gauge steel. And it's really, I wanted to build a building that was incredibly resilient, strong, but was able to hold soil. So this building can carry about 40 tonnes of soil. And it's kind of reverse engineered. So what I've done is use the soil as a foundation. And so there's no issues here with having soil on top because of the way that it's been designed structurally. And so we've used heavy gauge steel in most situations, and that's what everything's clad to internally and externally.
So it seems like your whole frame is all steel, no concrete.
No.
So I guess the goal is at the end of all this, Joost, that you can recycle the entire building, the whole frame, everything.
Yep.
Zero waste.
Well, as you know, I'm obsessed with zero waste. So if you can't recycle it, I don't want it.
Yeah.
Which actually counts out about 90% of materials.
Because most buildings are built with concrete, a bit of steel, some timber,
Yep.
you know, and then some adhesives holding it all together.
Yep. What do they say? Between 300 and 400 different chemicals are airborne when a house is finished. So glues, resins, coatings, paints, you know, so this building, what most people say when they walk in and they go, it doesn't smell like a house at all. And that's because we haven't used any glues, any synthetic materials. It's just all natural materials.
It smells like lawn here, or it smells like Apollo Bay. That's what it smells like. The Cypress macrocarpa.
Yeah. Well, I mean, I'm really proud of the fact that there's not one stick of FSC timber in this building. So everything's come from a farm. That seemed like a great idea, but it was a bit challenging. Oh, Lockie, we need some more timber. So he sets up the mill, cuts the timber. Oh my God.
So, Joost, can you tell me about your grand staircase here? Like, you know, what is this?
Well, this is just while we're building, of course, but I love using anything that's going away. So this pallet is really, no one wants them because they're 1.4 meters by a meter. So, yeah, they're a waste. And they come from Japan. They have car parts on them.
And so have you used them for anything else?
They're great, like for trellising and temporary fencing, and yeah, I love how the light goes through.
Even when you build the building, you don't get new formwork in. You actually just use other things to help you build.
Yep.
To make sure that even the way that when you're building something, it's got another use. It's not
like all this plywood has come off form ply that's been used several times. You know, so yeah, I mean, look, there's no doubt about it. It is more work, but this form ply would have been used half a dozen times to form concrete.
Yep.
And then they just, right, that's it. And then we go through it and cut it and use it for everything.
Yeah.
Come in, mate.
Thank you.
I'm excited to show you.
I can't wait. Come on, get me inside.
So we don't have a front door yet. It's arriving on Friday. But this is really technically still outside. So you're actually outside. That's how we were able to have the battery wall. So it's like a garage.
So this is your battery wall?
So this is the battery wall.
I wondered what that was. I thought it was an art installation.
Well, this is, you know, how obsessed I am with zero waste. Batteries are a disaster when it comes to recycling. Like, you can't recycle. They're difficult to recycle, especially the battery walls that are going into houses. And so I've just been researching, and then this, I came across nickel iron batteries about 10 years ago. I wanted to use them in King Lake. And everyone convinced me that they were no good. And then I came across this guy that was constantly answering questions on blog posts. And I thought, he must be in California. This guy really knows his stuff. And then he put his surname in one of the conversations. So I Googled it. He lives in Hillsville. And so I met him. And the following day, I was at his house. And so he's off-grid in Hillsville.
Tell us the benefit of nickel iron.
So the beauty about this battery is that at the end of its life, it can be completely recycled, 100%. And there's no toxins.
So it's literally just nickel and iron?
Yeah.
Okay.
And do you want to see something really crazy? You know how we need to sequester carbon?
Yeah.
That's what these batteries do. So these batteries have been cycled in for maybe 6 weeks.
Yeah.
That's carbon from the atmosphere. So these absorb carbon from the atmosphere. But not only that, this battery here is 100 years old and still works. As good as the day that it was made. So this is a battery that can be recycled, but it probably never will be. Like, my grandchildren will have these batteries in their houses.
Incredible.
So it's a battery that lasts a lifetime, and they're not more commonly known as Edison batteries, because Edison made electric car. He was obsessed with this technology. And but the factory was shut down in the 70s, mainly because you only sell them once, and then, you know. But yeah, we went to a guy last week, and he's off grid, and he's got batteries from World War II, and he gave us this one. So he said, you can have one. So that's our battery wall. And, you know, my dream is to set up a factory here in Australia to make these, because between 2 and 3 million houses they estimate are going to go with battery walls in the next 10 years. And
so tell us about how you charge these. Like, have you got solar?
Yeah, just solar. So Timbo, South Australian made solar panels.
So Australian made solar.
Yeah.
And have you got a good electrician installing those for you?
Mate, the boys from Breck. I'm doing their heading. What are you doing now? You added this. It's like I need. So here's a mushroom wall.
Oh, can I just ask about the electricals, because it looks like your cables coming down here are blue, not white. So what's special about the cables that you've got running in this place?
Well, as you know I've been working with plastic and trying to recycle plastic, and one thing I've learned is how toxic and terrible PVC is. So I'm trying to go completely PVC free in this house. So that cable doesn't contain PVC. All the plumbing is PVC free.
Okay.
And
where you can, you're running the water supply in copper.
Yep.
At the end of its life, it can be reused.
Yeah. So if it can't be recycled or if it's not recyclable or biodegradable, I don't use it.
Okay.
So it's that
easy. Sounds so easy, Joost.
Well, it basically cuts out 95% of the materials. If you go into Bunnings, it's like, okay, you may as well walk straight out because there's nothing there, you know.
All right, so sorry, you were going to tell me about the mushrooms.
Yeah, so, you know, the boys think that they've worked out how much energy, where to run power, and then, fuck, I forgot about the, you know, this. So what we're doing is the shower is on the back of this wall. So this is going to be a mushroom, basically a room filled with mushrooms. And we're using, like we all generate so much waste that can feed mycelium, whether it's coffee grounds, cardboard boxes, egg cartons, anything woody is a great feed stock for mushrooms. So we
Can you use the word mycelium? Can you explain to us what that is? What's that mean?
Well, mycelium is basically the roots of the mushroom. So the mushroom is really just the flower that comes out at the end. And
so the mushroom is like the fruit on the mycelium network.
Yeah. So you can see how many mushrooms are actually growing there. And that process takes about 2 to 3 weeks.
And so, Joost, why attach this to the back of the bathroom? Are you using moisture or something from the bathroom?
Like so we're funneling the steam from the shower straight into this room.
Ah, okay. So you're creating the perfect environment.
This produces carbon monoxide, and that is great for the plants that are in here. So we're trying to cycle it. So we basically have a little fan that pumps it straight into the greenhouse. So we've got a vertical greenhouse here. And that's got the biodigester.
So is that what this is?
Yeah, so this is like our cow. Have you ever made compost with cow manure?
I've made compost, not with cow manure, Joost, but tell me how.
Well, once you use cow manure, it's like the best compost you've ever made in your life. You go, wow. And that's because cows, they go through, the cow's stomach makes it go through a fermentation process. This uses exactly the same microflora. So we inoculate this tank with the microflora of the cow.
So using cow manure as like a starter?
Yeah, okay. Yeah. And then once that bacteria starts to grow, we feed it. So above this sits the toilet that goes directly into this, but also we've got an incinerator. So all the organic waste gets mulched and goes into this biodigester.
So you're literally feeding this shit?
Yeah.
And organic waste from the kitchen. So Joe and Matt will be cooking in the kitchen, sending that incinerator into here. Okay, cool. And is that safe?
It's safe. There's about 12 million people in the world that rely on methane for hot water, cooking, that sort of thing. So I'm just trying to bring this technology from the third world into the first world. But every single one of us produces about 1 kilo of waste.
Okay.
You know, it's scraps from the kitchen, and that can go into this. That's an hour of gas.
Oh, okay. So where does this come from? I've never seen this before.
This is from a bloody awesome company in Israel called Home Biogas.
Okay.
And I visited the guys last year in Israel, just outside of Tel Aviv. And they're just a bunch of awesome young guys that came up with this idea, and they wanted to bring an idea that they saw in India being used into the Western world. So they're now working and developing a system that goes into walls for apartments in places like Brooklyn.
Oh, okay.
So they want to make it a mainstream place so that when you turn the gas on for cooking or when you need heating, you don't even know if you're using methane or natural gas. So if you imagine like 7.8 billion people, 7.8 billion hours of gas per day. So we're sitting on this incredible energy source that we're not using. So
if Matt and Joe are living here, they're going to the toilet, they're cooking upstairs, how much gas do you think they're going to generate here?
Well, the guys in Israel calculated because of all the gardens here, it won't just be 1 hour. They think it could be potentially between 4 and 5 hours of gas a day.
Are they going to need that much gas?
Because, when you buy rhubarb, you're buying the stems, but the leaves are, of course.
Oh, okay.
So they say for every kilo of food, there's 2 kilos of other roots, and so that's all going to go in here. And so what happens here is this ferments does the fermentation process, but then it goes into a worm farm outside and adds a whole bunch of other microflora. So what I'm basically doing is creating the most unbelievable fertilizer that's loaded with microbes, bacteria, good stuff, to then feed the plants. So I'm creating
then Matt and Joe will then eat again?
Yeah.
So it's an endless cycle?
Yeah.
Yeah, okay.
So that's it's such an exciting concept to think about how much we can actually use, whether it's the woody stuff for the mushrooms or it's this. and then you've got all the solar energy. Like we're sitting on such a resource that we're not using.
I'm just thinking about this for, like one of our Nightingale projects. Imagine if we could do this and capture, 50 households.
And they have systems that they actually make for dairy farms that could be for up to 100 people. So they are working on much bigger systems. So it's an amazing concept. Okay. And then this timber is in late July. We cut down a macrocarpa tree.
So, which is also known as a cypress tree.
Yep.
And so I think that there's the most famous ones are down the Great Ocean Road.
Yeah.
There's big trees, but they're also used for, when you were telling me they were planted like at the...
So what we did, because we thought we were really smart, we cut all the trees down, and then they realized all the lambs were dying from wind and, the harsh conditions and no shade. Shit, we've cut all the trees down. So in the 1870s, I started planting trees, and the easiest one to grow was the macrocarpa, because you could just strike it from cuttings. And so they planted not thousands, but millions of macrocarpas starting in 1870.
So all of those windbreak trees you see next to farming land, that's all cypress macrocarpa.
Yep.
And it smells incredible. Like
it's that oil that actually makes it naturally termite resistant too. I love the smell of it, and it's you can use it for decking, and you can use it.
Yeah, because it also makes it really resilient, doesn't it? So you can put it outside. It's like a class 2 timber. Yeah, it's incredible.
Yeah, and it's getting mostly wasted at the moment. Like farmers burn it because when the trees fall over and the cows eat it, it actually causes abortions. It causes them problems because they gorge themselves on it. So farmers, as soon as they see that a tree is about to go or on its way, they'll actually cut it down. And whereas we should be using that for timber.
Yeah, okay.
And so this, as you know, like I'm a huge fan of agroforestry and getting farmers. So I can't stand monoculture, and all of FSC timber pretty much comes from a monoculture. So you're standing in a forest where all the trees are born on exactly the same day. Yeah. They've usually got the same parents. So they're all planted exactly the same distance apart, and you're standing in, there's no wildlife, there's no biodiversity, there's nothing. So we can't support that. And what's happening now globally is that governments are actually getting subsidies and carbon credits for cutting down wild old growth forest because they're replanting it with plantation forests, which is the most insane idea in the world.
So we're losing our biodiversity.
Yeah. So we've got like 130,000 farmers that even if they planted 10 trees a year and our carbon credits went to them to actually grow them properly and create really high quality timber, that transition can happen in as quickly as 20 years. But it needs people like us to say, let's use farm source timber.
So we're going to talk about this later because currently in our specification schedule, we start with Australian FSC timber.
Yeah.
And then that's the top of it. Well, actually after recycled, but still I feel like we've got to have a conversation about this and how do we do that at scale.
Yeah, and there's some really good, like Yang Yan Gert Farm in Deans Marsh is a really good example. They started planting trees 28 years ago.
You introduced me to them.
And they're now harvesting these incredible logs, and it's like, it's not like it's new, but if we use like 30% of our land, like the land that is suffering erosion and all these problems, if we use that, we could supply not only Australia, but we could export timber all over the world, really high quality timber, and have ongoing jobs for hundreds of years.
Oh no, didn't you know we only export coal and gas out of Australia?
Mate, don't talk to me about it. What do you think of the tiles?
The tiles are beautiful. What are they?
So this is Trent, who's the builder, helping me with this, Trent Alexander. I said, I need a concrete tile because I want the floor to earth, and I want concrete because you can just crush it and recycle it. I don't want a tile that's a ceramic tile that's gone through a baking process. And so he kept saying, there's a company that makes amazing tiles, and he couldn't come up with the name. So about 4 weeks later, he said, Sadler Tiles. Yeah. So I Googled it, and this old 80s website came up, and and there was a phone number on there. So I left a message, and this guy called me back, and he goes, "Oh, we're no longer called Sadler, but we're in Kyneton, but the business is actually based in the US now. But I do all the R&D here in Kyneton."
So what is this? Why does it feel like leather and not like concrete?
Well, Peter Sadler was a fine arts student at RMIT, and he, in the 70s, they asked the project was that you had to create fine art using industrial processes. So he poured concrete onto polished glass and got this finish. And
it's incredibly soft and warm, isn't it?
And you don't need to coat it. It doesn't need any finishing. It's just this is it. And there's floors. There's about 2 million square meters of this floor all over the world. Wow. Like Hugo Boss stores have it, and Southgate's got it. you know, so it's a really practical floor. As
Tough,
hard as granite.
hard wearing.
Yeah, and then at the end of the life of the house, you just crush it and use it again. But even better, we've forged this really amazing relationship, and he's now looking at taking, like, there's a lot of recycled content that's gone into this tile, especially for us. But he's also looking at completely removing sand, because I showed him the glass dust from the glass crushers for the restaurants, trying to find alternatives, you know, for this.
Well, because it can be a problem quarrying sand, right?
Yeah.
You know, like a lot of sand quarries here happen on, you know, First Nations people's, you know, land, and it's, you know, it can become incredibly problematic for the landscape.
Yeah.
Whereas you're saying use recycled crushed glass, using that as silica instead of using sand, and it has a whole new life to it.
He's actually found that the tiles have actually worked really well. So for him, it's like I've forced him to think outside the square, even though he spent his whole life making this stuff, and he's been really excited by it too.
And can I ask, why use a concrete tile inside a building that's so lightweight? Like everything, it's all just steel and, you know, this timber, and, you know, you can be lifted up and moved around, and you're using something that's dense like this, and it looks like you're going to get some sunlight on here. Like, what's the benefit of that?
Well, the only heating in this house is floor heating. Yep. So we're using a heat pump to heat the floor. So concrete is brilliant in that instance. So what we've got magnesium oxide board, which is this material.
Yep.
I'm obsessed with this material. We should be making this in Australia. This is a material that I was first told about by the CSIRO in 2005, and I wanted to use it on my house. This is like this tile, just cured at ambient temperature.
And so what is it? Literally just magnesium?
It's raw magnesium
Yep.
bonded with water. Like, it creates a really strong bond.
Yep.
And it's totally fire resistant.
Oh, really?
But best of all, you just crush it and turn it back into another sheet. It's completely recyclable.
Yep.
So it's got no silica. And Matt, who's been working here, normally suffers from cramps. And he said since he's worked here, he's had no cramps because of the magnesium.
Okay, incredible. And so you've got magnesium oxide.
Yeah, got magnesium oxide, got 2 layers of Durapanel, which is another brilliant product. And then this is we've got heating, and then this, and then these tiles.
And so by using the magnesium oxide, which is a dense product, by using the concrete, which is a dense product, it works as thermal mass, like a cellar, or like a stone in a hearth. And so it gets heated up and it stays at that temperature for longer.
Yeah, and in summer we run cold water through the...
incredible. So then it keeps the place cool.
Yeah.
And the way that our body interprets heat is 2/3 through radiant heat. So what's the surface temperature of this? That's how we experience.
Yeah.
And only 1/3 through air temperature. But strangely enough, in Australia, we obsessed with air conditioning, heating up the air, superheating it, and it all sits up there. I know. And we're still cold.
It drives me crazy, you know. And my mum lives in a house that's, you know, it was built in the 80s, and so this is going to actually, I should say that, this is actually going to be my mum's house in Monbulk, ultimately. So that's how we've been able to finance this project is I've got some really good partners like Mila and Bendigo Bank that have come on board as sponsors to allow us to have it at Fed Square, and Fed Square's kindly given us this site free to be able to do this as well. But my mum has basically paid for this house, which is going to be her home. So we've been able to do that, you know, kill 2 birds with one stone.
So it gets reused again?
Yeah.
It's not just like turning up at an exhibition.
It's made it actually a much more special project for me, because building a house for your mum is like, it's pretty cool. You know, because, you know, like my mum is one of those people that goes into a garden and then decides what to cook for dinner. So this house is a garden, you know. But
where does she live at the moment?
She lives in Monbulk on a farm, but she's sold her farm to my brother, and now she wants something smaller. Okay.
So tell us about this.
Again, another thing I found out from Justin Leonard from the CSIRO. I'm obsessed with straw, because straw is such a big waste product.
Is this the inside of that?
Yeah. So this is by the way the Rehau floor heating.
Okay.
But this is compressed straw. So they set up in 1952 in Ballarat, in Bendigo, and started using straw.
And so what's this on the outside of it?
Just a paper finish.
So paper on the outside of compressed straw?
Yeah, with no glues, no nothing. It's just pure compression and heat. And the embodied resin within the straw locks the material together. And then they use just a flour-based, a wheat-based glue to glue the paper on. And that's
like paper mache.
Yeah. And it
kind of looks and feels like plasterboard.
Yeah,
you know,
it is more absorbent than plasterboard, so you do need to. But of course, I want these walls to breathe, because I've added so the kitchen which you'll see upstairs is made with the macrocarpentry that we cut down, and we saved the sawdust and turned that into charcoal. And because I want these walls to breathe. So when
you sawed, you got this timber sawed, you got some sawdust, and then you got that turned into charcoal.
Yep.
And then you got the charcoal put in here.
Yeah. So these guys.
Why?
Well, because it actually was just a really random thing. But we're in Cuba. Jenny and I were on our honeymoon in Cuba. And I read in the paper there was these Danish scientists in Cuba trying to work out why Cuban hospitals didn't have golden staph. Didn't suffer golden staph the way that the rest of the world did. And they put it down to one thing that
universal healthcare?
No, well, they had a little bowl of charcoal in every hospital room. And what they'd worked out was that the charcoal acted like a sponge.
Yeah.
And that got me thinking, oh my God, why don't we just use charcoal in our building materials? And so in Sydney Greenhouse, I actually used it in the magnesium oxide. But here, we used 100 grams in every square metre. So I think we used about 120 kilos, maybe.
So these panels are absorbing toxins, if there are any, into the wall.
Yep. Forever. So
forever.
1 gram of charcoal has the surface area of a tennis court.
Okay. And so do you think that DuraPanel, have they just done that for this project?
Yeah.
Or will they do that beyond this project?
Well, they're pretty excited by it because this is like the random thing. They do testing on everything that they make, right?
Yeah.
And so they do a pressure test. So they have this as a walkable, trafficable roof where it's supported at both edges. And it can normally withstand 480 kilo pressure point load. And so they do a point load test.
Yeah.
With the 100 grams of biochar in it, it went up to a ton.
So you can drive a car on your roof, on your ceiling.
Like, what the hell? So they kept testing and they go, we don't know why. I've got some very smart friends and I've asked everyone, why would it be so much stronger? Like 100 grams of biochar is nothing, you know?
But
why does it make?
Yeah.
Anyway, that's...
is there something else in here? Can you show us what's in here?
Yeah, so this is the bathroom. And you can kind of see the layers. We've kept this off. You can see that the floor heating sits underneath there. The thing about straw bale buildings is there's always a lot of straw, you know, so as soon as there's a penetration, I mean, I love it. I'm always cleaning up, and here you can see, this is not your ordinary stud wall. This was actually a pine tree off a golf course, not off a farm. So I lied about that.
Yeah.
And then here, this is really cool. So another reason why I'm obsessed with having a concrete floor is because I want it, when you're walking here barefoot, you're earthed.
Yeah. Okay.
So you can see that there's a rod there connected into the ground. My nephew Yul, who's an electrician, has set this up for me. And so what you do is you can actually stand on here. So when we lay these tiles, we're actually going to lay them onto copper, which is connected to the earth outside. And so I don't know if anyone's seen that earthing movie. Josh Tickell and Rebecca Tickell from California made this great film. Brian is a good family friend of ours, Josh's dad. He lives in Lorne. Anyway, he made this film about this, so you should watch that. But when you're earthed, you can't have inflammation. So if you're walking on the beach barefoot, or you're walking in the grass, especially moist grass in the morning barefoot, you're earthed. You're connected to the magnetic field of the earth. And it's impossible to have inflammation. So what I'm trying to do is, whenever you're walking in this house, you're connected to the outside world. And that's another reason why concrete is a great conductor. So if I put a timber floor in here, you wouldn't be earthed. You can't be earthed. So you'd need to use steel, copper, or concrete.
I haven't taken my shoes off in about 2 years, guys, so I'll have to get my shoes off and walk on the grass.
But so what you can do is actually test for it, right? And so this is connected to the earth down here. And you'll see the difference. So if I'm standing on this mat here, can you see that? Yeah. We actually have to get the earth. Here it is. And this is just something that has made it so much easier with these tiles. And then what you do, you can actually undo that one.
I love, Joost, that you're so hands-on that you don't actually need a technical assistant here.
So see, I'm down to almost zero. So that the goal is to be 0, 0. So if I stand outside in the grass, which I can't because there's a fence there, I'll be 0, 0. So to actually know that when I'm walking around the house, it's the same as walking on the beach or walking. So that's another reason why I want floor heating. So my mum can just walk around all year long, you know, cold floor in summer and warm floor in winter.
Yep.
And then this massively insulated walls. So we've got double layers of Durapanel with a cavity, 35mm cavity in between for power and all that sort of stuff.
So double layer of Durapanel, it looks like it's only about 60mm thick.
Yep.
When you put that together, like what's the R rating? Do you know what you're getting?
No clue.
But you know that it's
off its head though.
It's off its head.
Everyone that
because it's continuous, right? There's no studs in between it where the insulation's missing.
Yep. Yeah. And just quickly, like this is another crazy. This is all the windows that are being used. So this profile comes from Switzerland, and thermally broken windows are a bloody nightmare to recycle, but because they're normally a whole bunch of different materials bonded together.
Yep.
This is all steel.
Ah, okay.
So when the sun hits the outside, this gets hot. This stays cool, and you can just recycle it. At the end of the building's life, you can just recycle them. I'm
really interested in this because it's hard for us to make a. You know, where a building loses all its heat or gets hot in summer is generally through the windows.
Yeah.
And so we specify thermally broken windows, but they've always got this neoprene gasket, which means that we can't recycle it at the end of its life.
It doesn't.
And also, they're always made of aluminium, which uses 6 times as much energy to produce as
steel.
As your steel windows.
Yeah. I love steel, especially because
I'm starting to get that.
Well, magnets pick it up so easily as well. We don't have a lot of time, so let's go upstairs.
Yep.
So this will always be open. So there's actually a front door, so that will be an insulated door.
Yep. Okay.
Even though because there's all louvers going in here.
Okay.
So this will be like an outdoor atrium covered with plants. So you'll be walking into like a garden. Come upstairs, mate.
I'd love to.
It smells like a sawmill, doesn't it?
It does, or a little bit like a sauna. It smells like cedar. I mean, obviously it smells like macrocarpa, but it also...
We're getting the guy who actually did the zinc at Federation Square is doing our bench tops out of zinc.
Oh, really?
I love zinc.
Yeah.
It's just, I went to a place in Paris and I asked them how old the kitchen was. It was 350 years old. It was zinc. And it just looked amazing, you know.
Well, because zinc doesn't rust.
No, and it's warm to touch. So when you lean on it, you know, steel and stainless steel is really cold.
Yeah.
Yeah, this is it's
and it's kind of softer, so you can get nice rolled edges on it.
Yeah. So this was a pine rafter out of a warehouse, which Andrew Aramore, a friend of mine, who made this whole kitchen from scratch with Lockie and a bunch of guys in Ballarat. And yeah, so this whole kitchen is made out of the tree that we cut down on the 25th of July.
So all of these drawers, all out of that Cypress macrocarpa?
Yep. And then we've actually used some sugar gum, which is another species that I'd really want to highlight because sugar gum can be coppiced. So we use so many poisons to kill competition. So when they replant trees, you know, they poison the soil to get rid of any competition. They plant the trees and then they often lay baits to get rid of the animals that then try and eat the young saplings. When you coppice something, the root system's there and it just regrows so fast.
So when you mean coppicing, you mean that you cut down the tree, the sugar gum, you send that to the sawmill, you leave the trunk and the root system in the ground, and then it takes off again. Yeah,
and you can do that, like the Japanese are masters, they've been doing that for thousands of years.
And the incredible thing about sugar gum, like I've seen some up in Ballarat, there's lots around there, but it's incredibly dense. It's a class 1 durable timber, which means you can put it outside, never oil it, and it'll just go grey, but it'll never rot.
Plus also all the limbs and the smaller stuff can go for firewood. Yeah. So the main trunk is great for, you know, stuff like this. So imagine, you know, if every farm planted 10 of those a year for the next 20 years, you've got, you know, a couple of billion trees that we can access in the future and I'll never have to plant them again.
Okay, I'm talking to all my farmer friends about planting some sugar gum.
So then we've got a garden out here, which is like the first terrace. And this is like the usable terrace. This window comes all the way out. So it'll be like rain protection as well. So all the cooking is here. Got big Miller induction cooktop, which the exhaust is actually not like it's connected, so you don't have to turn it on.
Okay.
It actually measures how much steam.
Yeah. And the beauty,
I'm a bit obsessed with Miele because
I'm obsessed with induction. So you're obsessed with Miele. I'm obsessed with induction because it's 40% more efficient than gas. So this is
I didn't know that.
Yeah, so because it works with magnetic fields rather than burning and heating something, it actually excites the electrons in the pot itself, in the steel of the pot. So,
yeah, right.
It's a direct transfer of energy into heat. So
I've got my mum's oldest brother, Case. He has bought and sold and repaired Miele his whole life.
Yeah.
So growing up,
everything was Miele.
Don't buy anything unless it's Miele. So we came to Australia with second-hand Miele washing machine, and then when Jenny and I moved in to our place when we moved out of home, we found one in the trading post, and it was 17 years old from a lady in Caulfield. She was going into a nursing home. Then when we moved into our house, we bought new ones, and I gave that washing machine to my brother, so 32 years, and then he had it for however long, So I love that they design stuff to last,
So tell us about this garden out here, Joost.
Yeah, so this is going to be filled mostly with apples and rhubarb, and there's some horseradish growing there. This is doing really well, actually.
And so
we only really planted this yesterday.
What are these?
So this is the ubiquitous 44-gallon drum.
Just a 44-gallon drum. But where do you get this from, and that it's safe to grow food in?
So there's heaps and heaps of people that recycle these, and all you need to do is ask for food grade. If you tell this, there's about half a dozen really good companies in Melbourne that actually recycle and wash 44-gallon drums. And all
so you literally just Google drum recycler?
Yeah.
Okay.
And they've got washing plant, and they can even tell you what it was used for. Mustard, olive oil, jam, once you build a relationship with them.
Yeah.
So on this roof, I've got them as normal pots. We've got them draining at the bottom. So this is actually the ballast for the building. This is the foundation, but I've done it in reverse, so it's sitting at the top.
So ballast, you're putting like the foundation at the top of the building, using the weight of this to hold the building down and stop it being blown away in high winds.
Yep.
Incredible.
And then I've used them as
which means historically people would put concrete in the ground, right?
Yeah.
And then you can't recycle the house.
Well, the Federation Square greenhouse in 2008 had 100 tonne of soil on its roof. But that was a 300 square metre building.
Yeah.
And so the engineer said, well, you can sit that building there, but you've got to use 100 tonne of soil. I went, beautiful. That's what I need.
I know something I can do with that.
Yeah.
So what are you growing here?
This is actually really incredible. This is tea.
Oh.
So this is a variety from Japan, and it grows the best green tea in the world. And this is asparagus. It's actually starting to flower. Some apples here. These are from JFT. And look, there's 1, 2, 3, 4, 5. They've only just flowered. 6, 7, 8, 9, 10. They're still flowering. So you can see how many apples are on that one.
Yeah.
That's a lime. And then we've just planted some snow peas and stuff yesterday. This is buckwheat. Joe specifically asked for it. And they're chickpeas.
I wonder what Joe's going to do with that.
Mate, that's the most exciting bit. I can't wait to see what these guys do. There's a banana there. So yeah, that's the most exciting thing over the next couple of weeks. We start planning this garden out.
And you've got one more level, Joost?
Yeah, let's go up.
Can I see that?
Yeah. So the toilet will be down there. And then we've got another aquaponics system going in here. So you're about to see the yabbies.
Incredible. Oh, what a view. nice place.
Here,
so you just pulled that yabby out of that half tank there?
Yeah.
So why have you got yabbies here, Joost?
Well, because yabbies are like the perfect urban crop for aquaculture. They're really resilient. They love eating like lots of leftover food. So carrots and leftover bread and so that's the stuff that we should be growing. And then what they're doing is, of course, providing nutrients for the
So their waste then puts nutrients into the water.
Yeah.
And then what do you do with that water?
You use it to grow vegetables and greens. And this tank here will actually be filled with barramundi.
Oh wow! And so do Matt and Joe get to eat some yabbies and the barramundi?
Yeah, and freshwater mussels,
okay.
and we've got like quite a few. And that will be that's probably the most productive 2 square meters in the whole house. So
So that's growing media in there.
Yep.
And so the liquid from the barramundi and from the yabbies gets pumped through that.
Yep.
And then the plants go up from that growing media.
Yep. And
Wow.
they're loaded with nutrients because, of course, they're reliant on the nutrients. So watercress, which is the most nutrient-dense plant in the world, will be coming off that,
Okay.
because it needs lots of water, water chestnuts, things like that.
Yep.
And so here you can see I've set them up as a wicking bed. Use the same barrels, and I've got them on here for water storage, but we don't need that here.
So can you explain just what a wicking bed is? Yeah. So there's water. I can feel water in there.
Yeah, so this is the ultimate zero waste design. A guy called Colin Austin, an Australian guy, who's still alive, he lives in Queensland, invented this for World Vision. When the famine in Ethiopia, they invited him to come and ask for his expertise. And he said, well, the problem is that they're losing nutrients. The food that they're eating doesn't contain nutrients because they get these massive downpours. So he invented the wicking bed. So nothing's lost. So when you water this, the water goes in there. And what I've done is the top I've reversed, so that sits like this. So what you can do is put a connection on here, which we'll do in summer, and you can have the water up to there, and the plants access the water from underneath.
So the water comes up from the bottom rather than putting the water on the top and then evaporating off.
And so you don't have insect problems on the top. You don't have, and the plants have always got access. But best of all, the food is much more loaded with much more micro life.
Because you're not just flushing the nutrients down into the drainage system.
Yeah, because soil microflora want the same as what we do. They want food, air, and water.
Yep.
The problem with the way we grow most food is that the water runs out and then the bacteria die. So all that microflora in the soil, whether it's mycelium and the billions and billions of microflora that actually make us, like there's microflora like Mycobacterium vacea, which is found in healthy soil, which alleviates depression and boosts serotonin levels. That's only in soil that has a combination of worms and mycelium and lots of rich microflora. So it tends to be found on forest floors that,
I think the other interesting thing is that this already seems to be flourishing, whereas you've been to one of our earlier buildings, the Commons, where the rooftop garden there wasn't a wicking bed. It just drained right through, and after a couple of seasons, the plants are really struggling up there.
Yeah. And I think the problem was that it kind of ran out of air.
Yeah.
So the soil became too compacted because the microflora, and that's why worms are so vital as well.
Yeah, okay.
Because they aerate the soil.
So worms can survive up here?
Yeah. I mean, as long as there's lots of organic material in there, then that's all they need.
And what have you got up here, Joost?
So we planted a blue lake bean. This is actually from my nephew, Miles. He grows veggies. Some oats. Here we've got buckwheat, more buckwheat for Joe. Chickpeas. We've got some corn. I've actually planted corn here amongst the oats. Got heaps of stuff.
Incredible.
We've got about 250 different types of plants.
And so do you think that there, the whole goal, right, is that you built a house that is essentially food positive, that it's enough Matt and Joe to live here, to get enough water, to have enough energy, to have enough food here.
Yep.
And also they want to have they like entertaining, right? So they're going to have friends over.
Yeah.
So it's actually going to be more than enough food for them to be able to.
That's my goal. Yeah.
Yeah. And so do you think that that's going to work?
Yeah.
Yeah, I think
I wouldn't be doing it for. Look, I don't know how well it's. I think that this house will be at its best in about 5 years' time.
I'm looking forward to
the
seeing
lemons and oranges and all that stuff.
I'm looking forward to seeing Matt and Joe come out of here heaps heavier than what they were when they came in.
I can't wait to. You're vegetarian, aren't you, Jeremy?
Yeah.
Yeah. So you wouldn't eat fish from here? No.
I would bend the rules for that.
Yeah.
Yeah.
Because it's part of the cycle here,
100%.
Yeah.
I know where it's come from. I know that it's sustainable.
Yeah.
Yeah.
And really,
I trust that Joe won't make it suffer.
And the thing is about, what I said to Joe is that this is it's like a natural ecosystem. So if they're not here, the whole building doesn't work. So the building is reliant on Matt and Joe living here and being part of the cycle.
Okay.
So as soon as they're gone, it dies.
So it's like any good ecosystem.
Pretty much, yeah.
Incredible. So
thanks for coming, mate.
No, my pleasure. As an architect who tries to, at Breathe, we try to work on sustainable projects. It's mind-blowing to see what you do and how you push it to the next level. and the way in which you think about everything. And I know that Bonnie Herring, you know, the director at Breed, you know, just can't believe what it is that you do when you think through these things, and she loves working with you on these projects. So,
well, I mean, you guys helped me so much with this, you know, the initial stuff as well. No,
so.
you did.
We're just trying to keep you out of trouble, Joost. But no,
we're not quite there yet.
Well, you know, I look forward to working with you again and learning more from you, and it's incredible.
Well, so much of this was actually part of the Queen Vic market.
Yeah.
You know, like so many of these ideas, like that mushroom, we were going to do 20,000 of those buckets, you know, when we did the audit on the waste that was being generated at the Queen Vic market.
Yeah, so this is something that you've been working on for many years, and often it gets stopped by bureaucracy or, you know, difficulties with planning, or because it doesn't fit under, you know, our planning scheme or our building code, you know, that talks about bricks and mortar and concrete and steel, but it doesn't really talk about a food positive system, you know, or reimagining, you know, a whole new housing typology and how to build smaller and more efficient and how to build for the future. So I feel like, you know, you're just about, you know, 20 years out or maybe 50 years out in front of all of all of our systems. But the great thing about this as a pilot, I think, is that it will lead to positive change. People will come here and be able to see this and say,
I think people are also really, I mean, look at Silo, you know, you build an example and then it just goes viral, you know, and I think that, and I'm not saying that this is the way it needs to be done, I'm just saying, you know,
this is one possible solution.
This is one possible solution. We can grow so much food by using, we generate the water, we've got the footprint, we've got the nutrients, so why are our system is so broken, you know, our food is not nourishing us anymore, because we haven't put the nutrients back in, so we haven't followed the cycle of nature. Yeah. And I just look at the opportunities that, like, I've got no doubt that in as little as 10 years, it'll be a very different ball game, and most of our food will come from where we live. And that means that we can then rewild and replant and you know, fix all the damage that we've done.
Yeah, and I did see Zach Bush came out and spoke here, you know, earlier last year, and he was talking about the United States largely fed itself after the Second World War from what he called victory gardens, you know. And so basically, you know, gardens in people's backyards where people nourish themselves. Yeah. And then over time it's become kind of industrialised agriculture, soil health has declined, the quality of nutrients in the vegetables you're actually getting is massively declining. So we're doing all of this work, spending all of this energy, shipping things all around the world to get less nutrients out of more food. It's kind of insane.
But
right?
I mean, the creative process for this with Joe and Matt has just been unreal as well, because I just think we haven't, like, there's 30,000+ plants that we can eat. So we've got 250. That's, you know, we're scratching the surface here. So if we actually adopt these systems and start to look at what's possible, I'll give you an example. Joe loves using milk. You know, we've got access to this incredible dairy farm, 12 cows, the best farm you could ever find in the world. The rest of the world.
Is Joe going to bring a cow here?
Well, she would love to, I'm sure, but I don't know if we've got enough grass down there. But unlike about a year ago, it was really bugging me that I knew how much she would said, I just don't know how I'm going to go without milk. So I started researching milk, you know, and obviously what are we going to get? Like pick 50 almonds from an almond tree. That's going to make about, you know, we can't grow soybeans. Yeah. But then I discovered tiger nuts. So I got some tiger nuts, planted them, and then realized they actually grew on my farm already, tiger nut grass. And then I said to Joe, this doesn't go back, like the earliest history that we've got of us using mammal milk, you know, there's evidence that it was 30,000 years ago. This goes back 1.5 million years ago. There's nutcracker man survived, 80% of their diet was this nutgrass.
So is Joe going to make tiger nut milk?
Yes. And not only that, she's been experimenting making cheeses and custards but see,
I can't wait to try that.
But that's what limitation, like if you're limited to a certain concept, it forces you to think, like that's the same with zero waste to silo. No, we can't have that.
But the interesting thing about zero waste and silo was it showed that it was possible. And so, you know, we started to see people, you know, doing simple things like, you know, reusing their cups. And then we see something pop up in London. You know, what's happening in London at the moment?
Well, I'm so proud of Doug. So Doug was our head chef in London, and I was at the time looking at doing a silo in London, in Brighton. The Brighton University invited us over, and I was exhausted at that time. And Doug's dad wasn't well, so he went back, hooked up with the Chancellor there, and found an incredible spot and opened silo in London without me. But you know,
now this zero waste idea in hospitality continues on.
Yeah.
And we're seeing, particularly, I'm incredibly proud Melburnian to see more and more hospitality venues looking at how do they reduce their waste in every way that they do things.
Like in 2008 for here, talking to Phil Sexton and Carla, these couple of winemakers, Gary Crittenden, can you put your wine in a keg? They go, are you crazy? Like we put it in a bottle, but they did it. And look at it now. Every single venue in Melbourne has wine on tap.
Yeah.
You're talking about millions, hundreds of millions of bottles that don't need to be made and don't need to be thrown out, don't need to be recycled. And then the whole, like even McDonald's has milk on tap now.
Yeah.
It's
you can go to the Vic Market and get your wine on tap at the Vic Market with your own reusable bottle. Like, it's incredible.
Olive oil. And I mean, it's just, I really hope that this is a catalyst. And like I said, I'm not saying that everything we do here is the way that it needs to be done. I just want people to get inspired and go, he's doing it like that. Well, what about if we do it like that? I just want it to be a catalyst.
Yeah. I think that you'll achieve that, my friend.
Well, with guys like you. Oh no, we're not allowed to do that. We're not allowed to do that. Oh no. Yeah. Thanks so much, Jeremy.
Thanks, mate. So close.
We made it almost to the end. Let's go and catch a yabby.
I'll put my hand in there. I'm hanging out for that.
It's amazing how much they eat,
I'm hanging out for the tiger nut milk.